Solutions are also referred to as homogeneous mixtures, where the macroscopic properties are uniform and do not vary throughout the sample. And these can be either solids, liquids, or gases. So here you have an example being brass, which is a substitutional alloy of 66% copper and 34% zinc. And the structure doesn't vary over large interatomic distances. And similarly you have steel, which is an interstitial alloy comprised of iron and a small percentage of carbon, which also has the same structure over large interatomic distances. Now an example of a homogeneous liquid is sodium chloride dissolved in water, where you can see that the water atoms surround the ions due to ion dipole interactions. And a homogeneous gas is air, which comprises percentages of the following elements, being nitrogen, oxygen, argon, and CO2 and other gases. Now in heterogeneous mixtures, the macroscopic properties depend on the location in the mixture. And these can also be multiphase. So for example, ice floats on top of water because ice has a lower density than water. And here you have concrete, which is comprised of cement powder and rock or aggregate mixed with water to form a paste, which hardens into a solid block. And oil floating on top of water is an example of a heterogeneous liquid. And fog is an example of a heterogeneous gas, where air and water droplets are distributed non-uniformly in the atmosphere.